All right, let's start. Just confirm number 4, number 11, 14, 28. Right. Haven't. I just, if you just look at the deadline for the worksheets, I just set the deadline first. I can delay the deadline. Okay, no worry. Okay, if you look at the deadline for the worksheets put in the Google Classroom.
Class
Okay.
11D is about
similar triangle. 11C is also about similar triangles.
But a bit difficult.
Because we haven't started.
Oh, hello.
Right. Now we'll start talking about similar figures today. Right. Let me share this one. Okay. Right. Now here, you remember we did some drawing yesterday, right? Now there's the case that if you still remember, I said AAA cannot be used for talking about congruent triangles, right? And therefore, let's see. I need a pen. Right. Now here, I want to show you what does that mean, right? Now, if we have, can you see that there's a triangle here? I want to move it. Right. Now, if I try to move this triangle, okay, and then if I put these 2 points together, okay, and then if I try to rotate it, then you can see that the angles overlap with each other, right? Therefore, it means, okay, the angles are the same here. Okay, both of them are 50 degrees. If I try to move it, okay, if I try to move the triangle, no, I just want to move this one. See, let me make it a little bit smaller. Then I can make it a little bit smaller, right? And then if I try to see whether I can move this one. Now you can see these 2 angles are also equal, right? And then here, these 2, the angles at the point B are also equal. Okay, check this one again, are also equal, right? Now, therefore, it means for these two triangles, okay, and the angles, okay, the 3 pairs of angles are the same. But of course, if you look at the size, okay, look at the size of these 2 triangles, okay, these 2. Okay, obviously, they are different size. Okay, one is smaller, one is bigger. Therefore, in this case, of course, we cannot say that they are congruent. Okay, therefore, if you have 2 triangles, okay, if you just have the information of the angles only, okay, in this case, AAA, okay, we know that this one must be the same, right? and then I just haven't written the angle. But in this case, okay, if we don't know the length, okay, if we don't know the length, okay, if you don't have any information about the length, then in this case, these two triangles, we say that they are similar.
係咪游水啊？陣間係啊，你一落堂即刻嚟咯喎。Hello，
Hello.
係啊，游水啊。
Okay.
係啊。
You go swimming. Okay.
佢係咪
Everyone knows that you are going to swimming because you know the video is put in YouTube. Okay, everyone knows that you are going to swimming and you are going to swim, okay, after the lesson, right? Now, then in this case, these two, okay, are similar triangles, okay? When we only know that the three pairs of angles are equal, okay? Therefore, be very careful, okay? If you have just AAA, okay, we cannot say that they are congruent, okay? We can just say that they are similar, okay, right? Right. Now, then also, okay, I would like to show you other similar figures, okay? And then when we talk about similar, okay, we don't only talk about triangles. Actually, we can have figures which are similar, just like this one, okay, just like this one, okay? They are similar, okay? But what we say that they are similar, usually, okay, if we try to say, yeah, but later you may think about, is this the case that when we change the size, okay, can we always have similar figures? Okay, do you know what I mean? If we change the size of something, can we always get similar figures? If I look at this one, how about this one? Now, it is very interesting if you look at this one. Okay, now before you draw anything on the here, okay, what are the angles? What are the angles? 90 degrees. Now, just now for triangles, okay, we know that these two, and also these two, they are the same. Then for triangles, they are similar. But how about if I have quadrilateral?
Well, big.
If it is a four-sided polygon, can we just say that's the two?
Angle.
Can we just say that the
Angle.
the figures are congruent? Okay, if for four-sided polygon, if I have four 90 degrees, what do you think? It means if I have another quadrilateral which has four 90 degrees, are these figures always similar? Do you know what I mean? If there's another figures, okay, which has four 90 degrees, okay, is it similar to this one? Can anyone draw a quadrilateral with 4 90 degrees? Or someone said no. Then do you know why? Or can you draw? Yes, very good. Now, therefore, that's the case that be very careful, be very careful. Now, when we talk about similar figures, okay, we in triangles, in the case of triangles, okay, we have something called AAA. It means we just look at the angles, okay. The 3 pairs of angles are the same. Then we say that the triangles are similar. But this is not the case when we talk about quadrilateral, okay? Or later, maybe 5-sided polygon or 6-sided polygon, okay? We are not quite sure, okay? I saw your drawing, right? Because we can have a square, okay, which is having um 4 right angles, okay, and then we can have other. Okay, very good. We can have other rectangle, okay, with different shapes. Okay, right. I would like to clear the drawing first. Now, if you look at this one, okay, even it is a right angle, if I change the size, I'm changing the size. Okay, of course, you will find that the shape, okay, it is a rectangle, but we cannot say that they are similar. Okay, if a rectangle looks like that, or another rectangle looks like that, okay, we don't say that they are similar. Okay, or we can have something like that. Okay, now therefore, if other than triangles, okay, for other figures like this guy or a polygon having more size, okay, when we look at the angles, we also need to look at the size, okay, or the length of the size more precisely. Okay, sometimes, okay, if I show you uh, another another case, let me clear the drawing first. Now, I'm not sure whether uh, you have tried this before. Say, for example, if you have Microsoft Word, and then sometimes maybe say we put pictures. Okay, let me get anyone. Okay, like this one. And then if I change the size, if I want to change the size of this picture, hey, let me see. Oh, I'm not showing you that one. Let me see. I want to show you this one now. Yes. Now, for example, if you have Microsoft Word, okay, and then I have put a picture in this document. And then if I think that, okay, it is too big, I want to change the size. Now, if I move, have you tried this before? If I move in this way, can you see that? Okay, the picture is smaller. The picture is smaller, but the case is that it is not similar to the original picture. Okay, this is the original, right? Now, if I just change in this way, okay, now it is smaller, okay? Of course, it is not similar to the first one, right? You know what I mean? Okay, the picture is, we say that distorted, okay? Okay, the shape in mathematics, okay, in mathematics we say that they are not similar, okay? Right. Now, therefore, what we need to do you know how to change the shape so that it looks similar? It's for Microsoft Word. Do you know that? Press Control. Press Control or press Shift. Which one? Anyway, we need to press something, right? And then when we press something, and then we use this one instead of changing this one, right? And then we press. Okay, your classmate suggested that we need to press the Control key. Now, when we press Control key, that's the case that you'll find, okay, the pictures is getting smaller, but it we think that, okay, just by observation this time, okay, it looks similar to the original, because in this case we keep something called computer lesson, right? Now we keep the proportion. Okay, we keep the proportion. It means if I want to cut this part smaller by 1/2, then in this case, we also need to cut this length by 1/2 like that. Okay, so that this one, okay, is similar to the original one. Okay, right? Let's see. Can you see that? Almost, okay, right? You know what I mean? Okay, if the horizontal distance, okay, I cut it by 1/2, then the vertical distance, I also need to cut it by 1/2. It means I need to keep the proportion. We say that we keep the proportion. Okay, every length should be shortened by the same proportion. Okay, right?
Side proportion.
Right.
And then
Okay.
angle proportion.
Okay, right. Okay, you know, fine. Then we don't need to have the lesson. Go and do your homework. Right. Okay. This is what we mean by proportion. Okay. Now, and then you can look at your textbook. Then you will find there are some other examples. Okay, on page 26. Okay, and then you can try them later. But anyway, I want to ask you another questions before I move on. Before I move on.
Bye.
Who is that? Okay, right. Let me see. Do I have the right spot? Yes, I have the right spot now. Okay, right. Now, just now, okay, when we talk about triangle, oh, my pen is not working. Right, let me see. One more question before we move on to the similar figures, similar triangles. Now, if I have triangle, okay, if I have another triangle, okay, if these two are the same, these two are the same, these two are the same, okay, then we say that triangle ABC congruence to triangle PQR, right? And then SSS, right? How about for four-sided polygon? If can I have two four-sided polygon? Both of them are having same size. I mean, all the four lengths are different. Yeah. Are they congruent? Are you sure that they are congruent? What do you think? Can you think of an example that you are not sure whether they are congruent or not? Right. Yes. If we have something called rhombus, do you know the meaning of rhombus? Or diamond. Okay. And then if I have a square, okay, four pairs of sides are equal, but the case is that they are not congruent. They are not congruent figures. Okay. Therefore, this one, okay, just before we move on to the similar triangles, I just want to remind you that for side, okay, this one, okay, when we talk about congruent figures, okay, side, it is true for triangles only, most of the case. Okay, if I have three pairs of sides are equal, then we can just confirm that two triangles are congruent. But when we talk about polygon with more sides, okay, like four-sided polygon, if even all the length are the same, okay, the figures may not be congruent, okay. Therefore, at this moment, okay, we just focus on triangles, because for triangles, the case will be simple, okay. Therefore, we learn something about the triangle first. When we have figures with more size, when we have other polygons, the case will become a bit more complicated, okay. That's why we focus on triangles in Form 1, okay, right. Then now we can move on to similar triangles. Now, just now, let me clear the board first. Now, just now, we know that for triangles, because, hey, for triangles, if I have two triangles, okay, with the same angles, okay, if these two are the same, actually, I am quite sure that this one, okay, must be the same, okay. And then just now we also have seen that in this case, okay, the shape, okay, we say that same shape but different size. Then in this case, we call them similar, okay. For congruent means same shape but same size also, then it is called congruent, okay. Therefore, there's one case you can tell whether two triangles are congruent. You check the angles, okay. If you can confirm that all the three pairs of angles are equal, then we say that the two triangles are similar. When we talk about similar triangle, the symbol is just this one. This is the symbol for congruence. Okay, right. Therefore, if I have two triangle, okay, this is say ABC, this is PQR. If all these three angles, okay, are the same, then we write triangle PQR similar to triangle ABC. Okay, and then for this case, if we have the information of the angles, then we write that A here. Okay, right. Now, then we also have another case. Now, just now, when you saw me to change the picture in the Microsoft Word, okay, just now, if you still remember, there's a book. Okay, if I want to change the size so that the two figures are similar, I just told you that if I shorten the side, this side by 1/2, then I need to also shorten this size by 1/2 so that if I have figures like that, okay, then this one, okay, will be similar to the original pictures. Therefore, there's another case that if we want to have a similar triangles, if I want to have two similar triangle, we can do something like that by changing the size. For example, if I make this one shorten by 1/2 and then this one shorten by 1/2, okay, and then it means I have a triangle, okay, this small, and then I have this length like that. Okay, for example, if original for this the bigger triangle, okay, if this is 8 cm, if this one is say 6 cm, this one is 5 cm. If there's another one here, 4 cm, 2.5 cm, 3 cm, okay, then you can see that it means I make the triangles smaller, okay, by shorten each length, okay, by 1/2, okay, shorten the length to 1/2. Then in this case, we change the size by the same proportion, okay, just like the case when I change the picture in the Microsoft Word, okay, in the same proportion, every side. Then in this case, we can also get a similar figure in this case. And this one, we say that the corresponding, all the corresponding sides are in proportion, okay? And you may find the reference in your book in page 36, okay? And then we say that three sides proportional. Okay. Let me show you some more examples. Uh, let, Now, I have two triangles here. Can you see that? Okay. If you look at them in this way, if I tell you that these two are in one pair, okay, and then if I want to look at the length, okay, look at something called proportion of the length. I do something like that, AB divided by AC, okay, which is 9/6, okay, or you may find it, oh, oh my God, I want my, yes, where is my rubber? Oh, never mind. Now, then if I want to have BC divided by CD, now there are two triangles like that. If I separate them, I just forgot to separate them for you just now. Now it means there are two triangles in this way. These two triangles share the same length, okay? And then sometimes, okay, we need to look at the length in this way. Okay, for example, I give you a hint, AB and AC, AB here, and AC for this triangle, they are in one pair, okay? Then if we try to find the proportion or ratio, I do something like that, okay? I do a division, okay, 9/6 for AB divided by AC. And then if I look at another pair of sides, hey, what's going on? I cannot change the color. Right. Now, if this length, hey, uh-oh, oh, I know what's going on. Hey, I have problem in doing the drawing. Let me try again. What problem? My iPad pencil does not work just now. I don't know why. Okay, it's okay now. If these two, BC, if you look at these two together, okay, then I have BC divided by CD, okay, the length 7.5/5, okay. Now you can try to simplify the values, okay, 9/6, okay, it becomes 3/2, right? And then you try to simplify these two also. This one. Can we get the same? Which is 15 divided by 10, right? And then you try to simplify by 5. It is also 3/2. Okay? And then this one, this length of the triangle on the left should pair with the triangle, okay, AD on the right, okay? Therefore, in this case, if I try to use AC, this AC refer to this triangle, okay, the one on the left, okay, divided by AD, this one, AD, which is 6/4. Okay, and then we can do the simplification, the cancellation. I also have 3/2 here. Now, therefore, in this case, you can see that if there are two triangles, if I have the size, if I try to have the size in pairs, and then if I do the calculations, the divisions like that, then you will find you always get the same answer, 3/2, 3/2, 3/2 in this way. Then in this case, we say that the three sides are proportional, or we just write it in short form. No need to care about the grammar. Okay, three sides proportional. Okay, then in this case, these two triangles are similar. Okay, similar. But this one you may find it a little bit more difficult. Okay, because when they are different in size, okay, some people may find that difficult to look at the shape, and then difficult to pair up the angles. Okay, and when we talk about the two triangles, okay, we say we need to write down, say, triangle ABC, okay, similar to triangle. Then you need to follow the sequence A B C A B. Then in this case, for the smaller triangle, will be AC AC. Okay, A B C. If you follow the color, therefore we have triangle ABC similar to triangle ACD. Okay, I just give you some brief idea what you need to do later. Okay, we will have some more example, no worry. Okay, this is more or less you are going to do. Okay, that's why just now someone said that he which is, I think you find that worksheet 11D is a bit more difficult. Okay, that's the case we need to do. Okay, for worksheet 11D. Okay, right? Okay, up to this moment, do you have any problems? Or do you have any questions? Any one of you? If you have question, you can ask now. Any questions? No. Now, then maybe we do some practice, okay, before we move on. Okay, we do some more practice. Okay, right. Okay, right. Hey, let me change to this one. Hey, okay. Maybe we start with some simple question first. This is triangle A, B, C. This is X, Y, C. Okay. Okay, this one. You need to find the unknown. Okay, anyone wants to try? Anyone? It means the unknown is the unknowns are M and N. M and N. Like who is that? Right. Okay. And how about the other one? Okay. Yes. Now, usually if you're given the information like that, okay, A, B, C, and X, Y, Z, like that, we have do it. We have given you the information, okay, in a sequence. It means A pair with X, and then B pair with Y, and then the other ones, this C, okay, pair with C, okay. Therefore, in this case, we know that these two angles are equal. Therefore, M is 90 degrees. And also this one, C, okay, pairs with this, okay. Therefore, angle C is 25 degrees. And then let's try another exercise. Uh,
Oh.
who is that?
Oh.
Someone is turning the pages of the book. Hey, what's going on?
Hey.
Right. And then how about this one? Also find the unknown, find X and Y. What do you think? How will you do this one? Okay, right. Now, because when we write the triangle, okay, we need to pair the angles correctly, okay. Therefore, in this case, if we look at this one, we can already got the information which angles pair with which one, or which side is pair with which side. For example, in this case, if we look at BA here, then it pairs with ED. That's why one of your classmates wrote something like that. Okay, A, B, and ED. Okay, and then because all the sides should be in proportion, okay, for similar triangles, it means they are same shape but different size. Therefore, it means for this triangle, for this one, I have the length BC, I have the length CA, and then I have the length BA, right? Okay, and then for the other triangle, for the other one, this one, okay, if I look at BC here, then I follow BC pair with EF, BC pair with EF. If I look at CA pair with FD, okay, and then finally for BA, therefore BA pair with ED, right? And then because they are in proportion, therefore we know that these are all equal. It means if you use the length BC divided by the length EF, the number that you get or the value that you get should be equal to the length of CA divided by length of FD. Therefore, in this case, okay, your classmate has calculated the value of AB divided by ED, which is 3/2. Okay, but be very careful. You have to follow. Okay, you have to follow. If you put the bigger triangle, the length of the bigger triangle in the numerator, you have to do it for the other two pairs. Okay, therefore in this case, this is 3/2. This is 3/2. Then you need to use, just now I use BA here. Okay, this one. Then in this case, when you do this one, AC should be also coming from this triangle. Okay, and then AC pair with FD. Therefore, AC divided by AC divided by DF, okay, which is in this case X and 10. Therefore, X over 10. And then same number, same as this one, okay, 3/2, okay. And then we solve this equation. We solve this equation X over 10, which is equals to 3/2. And then we times 10 on both sides. We times 10 on both sides. Why it is 24? Hey, X over 10, X over 10, yes. Okay, we times 10. This is really 24. X over 10, 3/2 times. What do you think? Is this 24 really? X over 10. Okay, right. Why? Oh, it is not 10. It should be 16, right? Hey, this one. Okay, it should be 16. Sorry. Because I look at this one. It looks like the number 10. Okay, it should be 16. Okay. Hey, my pencil is not working again. Hey, right. What's going on today? Why? My pen is not. Okay, you correct it. You correct it for me. I don't know what's going on today. My my pens just always stop working. This part, this part. Because I just now I saw this one as 10. Okay, it should be 16. Yeah, this is not correct. You are correct. Okay, 24. Okay, and then same for this one, same for this one. Okay, we use BC. Okay, BC should come from the triangles on the left. Okay, and then define the length. Okay, the corresponding length on the of the triangle on the right. Therefore, we have BC divided by EF, which is Y. Okay, divided by 12. Okay, should have the same value, 3/2. And therefore, when we solve this equation, then we will get Y equals 18. Okay, right. Now, it's almost 2 p.m. We can stop here. Now, you can try, if you haven't done the worksheet 11C, you can do worksheet 11C first. Okay, then for that part, usually you are asked to find the unknowns like that. Okay, just similar to the examples, similar to this one. Okay, it means you are given a pair of similar triangles, and then you may need to find the unknown length or unknown angles like that. Okay, for worksheet 11C. And for worksheet 11D, okay, a little bit more difficult because for that one, you need to tell, okay, which angles, okay, which triangles are similar. Uh, why Why you think that we don't have lessons on Thursday and Friday? What's going on? What happened? Because they are holiday. Oh, yeah. Oh, public holiday. Okay, right. Okay. Do you want to have a break? You want to have a break? I'm okay for that. I just forgot that they are public holiday. Thank you for telling me. Okay. I'm okay with that. Then we can just continue on Monday, right? Am I correct?